Okay, so today's topic is on estimating and interpreting graphs. So estimation is the process of getting an approximate answer to our question. So we first need to review the place values for whole numbers. Notice this is a whole number, not a decimal. We'll talk about decimals in a minute. So the very last place, the 7, is in what we call the ones place. The 0 is in the tens. The 8 is in the hundreds. So that's 807. The 6 is in the thousands spot. The 4 is in the 10,000s. The 3 is in the 100,000. The 2 is in the million spot. And then that kind of repeats. Now 8 would be 10 million. And 7 would be 100 million. And then the 4 would be billion. And this just keeps going, so it would be 10 billion, 100 billion, and so on and so forth. So which digit is in the 10 millions place? Well, in the 10 million spot, we can see that the number associated with the 10 million spot is the 8. So 8 is in the 10 million spot. And then it asks what the 3 is in which place. Well, look at all of the digits. There's only one 3. So the 3 happens to be in the 100,000s spot. So now that we know what the digits are, we're going to learn how to round. So the steps for rounding is mark the place that you are rounding to, and this is what we call the rounding digit. Next, I want you to locate the digit to the right of the rounding digit. This is called the test digit. Now, if the test digit is 5 or higher, greater than or equal to 5, then I want you to add 1 to the rounding digit and replace all the digits to the right with zeros. But if the digit is less than 5, that's 0, 1, 2, 3, 4, keep the rounding digit the same and then replace all the digits to the right of the rounding digit with zeros. So our first example says round 568 to the tens digit. So we're going to underline the tens digit, which is 6. That is the rounding digit. The digit to the right of it is called the test digit. So 8 is the test digit. So we're going to decide if 8 is greater than or equal to 5 or less than 5. So 8 is higher than 5 or greater than 5. So that means the 8 tells the 6 to go up 1. So we're going to take the 5 that stays the same. The 6, which is the rounding digit, goes to 7, and then everything after that replaces with a 0. Let's do it again. Round 278,362 to the thousands. So we're going to underline the thousands. That's the 8. Then the 3 is the test digit. Now, because 3 is less than 5, that tells the 8 to not move or not change. So we have 278,000, and then everything past the rounding digit is going to be replaced with zeros. Round 248,982 to the hundreds. So the hundreds here is the 9 digit. So the 8 is the test digit. We're rounding to the 9, which is the rounding digit. So the 8 tells the 9 to move up. Now, 9 is difficult. That's the highest digit it is that there is with only one digit. So what we have to do is if we move 9 up to 0, then that has to carry a 1 over to the thousands digit. So we have 249, and then now we put zeros behind it. Now this also looks like we rounded to the thousands, because if you rounded to the thousands, it's the same. But in this case, rounding to the hundreds and rounding to the thousands is the same, which is 249,000. Next, we're rounding 3,456,789 to the 10,000s. The 10,000 spot is the 5. So the 6 is the test digit. The 6 tells the 5 to move up to a 6. Everything to the left of 6 stays the same. Everything to the right of 6 gets replaced with a 0. Now we can round for whole numbers like we have been doing, or we can round for decimals. So let's go through the place values for decimals. Notice that there's a decimal point right here between the 2 and the 3. So that means the digit to the left of the decimal point is the ones digit. That means the 1 is the tens digit. Now, just like in whole numbers, this would continue up hundreds, thousands, 10,000s, 100,000. But we're mostly focusing on the things to the right since we haven't talked about those yet. So the point 3 is in the 10th spot. The 4 is in the 100th spot. So that's 100 with a TH, just like 10th is 10 with a TH. The 5 is in the 1000th. Six is in the 10,000th. And the 7 is in the 100,000th. So it's kind of similar to the whole numbers except with a TH at the end, and there is no 1th position. It starts at 10th position. So now let's practice. So we are rounding to the nearest 100th. So if the 7 is the 10th, that means the 4 is the 100th. The rules are the same. So the 4 is my rounding digit. That means 6 is my test digit. Because 6 is greater than 5, the 6 tells the 4 to move up to a 5. Now everything before it stays the same. Everything after it turns into zeros. Now on to the right of the decimal place, we don't need to put in zeros. That's just not all that helpful. Next, round to the nearest 10th, 113.246. So the 2 is my rounding digit. That means the 4 is my test digit, which tells the 2 to stay the same. Because 4 is less than 5, it stays the same. So we have 113.2. Next, round the nearest thousandth. The thousandth is the second 2. The 2 is our rounding digit. The 7 is the test digit, which tells the 2 to move up. Because 7 is greater than 5, we change the 2, which is the rounding digit, to a 3. Everything to the right of it zeros, but we don't write zeros. And then nearest 10,000th, we have 10th, 100th, 1000th. 10,000 is right here, the 7. Now the 8 is the test digit, which tells the 7 to move up because 8 is greater than 5. The 7 changes into an 8. Everything before that will stay the same. Everything after it turns into zeros, but we don't need to write that. All right, next we're going to estimate the following computations by rounding the numbers so that they can be found easily. Now this section doesn't actually tell you exactly what to round to. You have to kind of estimate that yourself. So we have 248 plus 797. Well, 248 is very close if we're rounding to the tens, 250. And that's a nice round number. And 797 is really, really close to 800 if you're rounding to the tens or if you're rounding to the hundreds. Now I'm going to put this little squiggly equal sign. That squiggly equal sign means approximately equal to. I can't really say that 248 plus 797 does exactly equal 250 plus 800, but it's pretty close. So 250 plus 800 in my head, I can add that really easily and I get 1050. So it's approximately equal to 1050, just trying to get a quick estimate. Now if I really wanted to add those up, I could line them up and add or get a calculator out, but that's not exactly what I'm trying to do right now. I'm just trying to estimate a pretty close answer. So the next one is decimals. So we have 13.93, 4.08, and 14.34. So let's round to the nearest whole number and add the whole numbers. 12.93 is really close to 13 if you round to the nearest whole number, which is the 2 and the ones digit. 4, that's really 4.08 is really close to 4. 24.34, if we round to the nearest whole number, that gets us 25. And now I can add these easily. Again, I'm going to put the squiggly equal sign, which means approximately equal to. And 13 plus 4 is 17, and 17 plus 25 is approximately 42. Now, if you went back and added these exactly with a calculator, you'd find that my answer is 41.35. Now, that's really close to 42, but we got our answer without having to get a calculator out, without having to do a whole lot of computation, and it's pretty close. The one before, I think, adds exactly to 1045. Now, those aren't the real answers. The real answers that I asked you to get were estimating, so I want you to estimate and get the best answer you can. All right, let's go to the next one. 1.97 times 305. 1.97 is really close if you round to the nearest whole number, 2. 305, again, really close to 300. So if I multiply that, I'm getting 600 really quickly. Now, if I was to multiply 1.97 times 305, that would take me actually kind of a long time, and it turns out that the actual answer is 600.85. So I got 600, which is possibly a good enough answer for today, pretty quickly. The next one, 52.34 divided by 5.11. So if I round to the nearest, let's say, tens digit, that gives me 50 divided by, round to the nearest ones here, 5. 50 divided by 5 is 10. And that's pretty close. If you were to work that out, again, dividing decimals takes quite a long time, and you would get 10.24, which is really close to the correct answer. Okay, here's a word problem. You and a friend ate lunch at Ye Old Cafe. The check for the meal showed soup for $3.40, tomato juice for $2.25, a roast beef sandwich for $5.60, a chicken salad sandwich for $5.40, 2 coffees totaling $3.40, apple pie for $2.85, and chocolate cake for $3.95. So you're going to try to total up this bill pretty quickly. Let's say you're trying to divide it up between you and you want to estimate. So let's just round to the nearest whole number and see what happens here. So the tomato soup was $3.40. We're going to round it to 3. The tomato juice was $2.25. I'm going to round that to 2. Roast beef was $5.60. Because the 60 is bigger than 5, I'm going to round that to $6. The chicken sandwich, we're going to round that to $5. 2 coffees totaling, so that's both of them, is $3.40. I'm going to round that to 3. The apple pie, that's $2.85. That 8 tells the 2 to move up to a 3. And then the chocolate cake for $3.95. The 9 tells that 3 to move up to a 4. So when I add this all up, 3 plus 2 is 5, plus 6 is 11, plus 5 is 16, plus 3 more is 19, plus 3 more is 22, plus 4 more is 26. So I'm about $26. That's what I would expect to about pay for this. Now, if my bill came back and it was much higher than 26, then I would contest my bill, or if it was much lower, I would see what was accidentally left off. So just in my head, I was able to come up with a bill of $26. If you actually add this up, it turns out to be $26.85, which is really, really close.